Lesson 7 of the unit builds on the previous, solving inequalities and solving system of equations, and today we're going to solve systems of inequalities. As before, what does it mean to solve this? Well, as before, what it means is we want to find the truth. And that involves finding all x and y values that make both inequalities true at the same time. Make both at the same time. So if you look back at your notes over the last 2 or 3 classes, you will see the same language. You will see that these things are coming together. So as with last lesson, when we're solving a system of inequalities, we focus on the equations, draw those dividing lines, and see which side of those dividing lines the answer is going to be on. So we're just going to go ahead and plot these two lines first, and then we'll decide should it be dashed or should it be solid. And again, you're going to use a ruler, but I'm gonna do this line in blue, and I'm going to do this line in green. And as always, this computer is not good for drawing lines, so I'm just going to do it by hand. So again, our blue line, y-intercept of 2 and a slope of 1. So I'm just doing some points. They're a little further apart, so it doesn't get all super messy, but there is a line that has a y-intercept of 2 and a slope of 1. Our other line has a y-intercept of 4 and a slope of -1. So I'm going to plot all those. And I'll just do a few. And again, you're going to use a ruler right after we decide on something. So in this question right here, then the question now becomes, is it dashed or solid? And both of them are dashed because they do not have the and equal to on the bottom. So I'm going to dash my lines. My green line dashed. And again, they do intersect at the same place they did from the lessons before, but I really don't care about the intersection. I'm looking for the solution region, not the actual point of where these lines cross. So in trying to find the truth, remember what has to happen. The truth is going to be true for both. The solution is going to be the truth for both of these inequalities, and the solution to each inequality is a shaded region. So I'm going to go ahead and shade in the region for the blue graph. And the blue graph is, again, I'm not going to go through how we did it. We did it last day. But for the blue graph, it's underneath. So I'm going to go ahead in blue, and I'm going to shade in this solution region. So this is what we did last lesson, and I don't think we need to go over it again. But there's the solution region for the blue line. Well, what about the solution region for the green line? We want to know when y is going to be less than or greater than, negative x plus 4. And where it is true there is above the green line. Above the green line. So here's the truth for that other inequality. And now it asks you a question. Where do you think the truth for both of them is? And it's similar to the answer of where the truth to an equation was. It's where they're the same, where they're both the same, and they do have that shared intersection point, but the other place where both of these inequalities are same at the same time is where they overlap. So here's our key idea. The solution pictorially is where the two overlap. And you can see it in my picture, where the cross hatching is, meaning where you see vertical and horizontal lines. That's where our solution is. And again, cross-hatching just means like that. There's our cross-hatching. Now, in order to see algebraically, in order to check your answer, what we simply have to do, like all the other things with inequalities, is pick a point in the solution region and check it out and make sure it works with both. Now, here's why we don't want to do a random one. There are 4 regions there. If you look, this grid is cut top, bottom, left, right, if you want to think about it. So if I did test points, it would not be efficient just to try to figure them out randomly. So we want to choose a point in our solution region, and the point I'm going to choose is 10, 0. Again, it really doesn't matter which one we choose, but that's the one I'm going to pick. So I'm going to plug that into each one of the inequalities, and I'll color code it blue and green. So is 0 less than 10 plus 2? Is 0 less than 12? That's our first inequality, and absolutely that's true. But in our second inequality, is this true? Is 0 greater than negative 10 plus 4? Is 0 greater than negative 6? And I think the answer is yes. So again, for the solution to be correct for a system of inequalities, it has to make both equations work at both times, and pictorially that turns out to be where the 2 inequalities overlap. There's the sameness. There's the sameness. So again, this is looking very familiar. When we have to solve a system of inequalities, we're still looking for the truth. And graphically, the truth is where the 2 inequalities overlap. And algebraically, the truth makes both inequalities work simultaneously. Both inequalities work simultaneously. So let's look at a quick couple of examples. And again, the questions are going to look the same. We've done these graphs before, so I'm not even going to talk about them. I'm going to graph them really quickly. So there's my first one. I'm going to color code it blue. My second one, color code it green. And again, what you should see is that this gets cut into 4 regions, and we have to decide which region the truth lies in. So again, we've done these problems before. I said imagine you're plugging in a 0 and a 0. So in the first one, the green line, here's where my truth lies. It lies below. And again, all I've done is I plugged in 0, 0. And in the blue, the truth lies below in this section to the right. So for the blue, it lies over here. Again, I plug in my value, and again, I chose 0, 0, and the truth is over here. And again, where is this thing overlapping? Well, it's overlapping in the bottom right corner. So if we're going to go ahead and pick a point, I'm going to choose 0, 0. Again, I could have chose 5, 0 or 5, -5 or whatever you want, but I'm going to choose that one because, again, it's easy to check. So I'm going to go ahead and plug 0, 0 in to the blue. And when I plug in for blue, I get 0 is less than or equal to 2 times 0 plus 1. 0 is less than or equal to 1. That's true. And when I do my green one, 0 is less than or equal to -1/2 times 0 plus 6. 0 is less than or equal to 6. And that's true. And there's my solution region. So one more example. And again, we've done both of these before as well. We've done them individually. We've looked at them solving a system of equations where the line crosses. And finally, we're doing a system of inequalities. So I'm just going to plot these and decide, is it dashed? Is it solid? And if you remember, this one, you needed to go further down. So I'm going to go ahead and connect the dots, and given that it is less than, it is a dashed line. So there's our blue, and our green is -5. We can plot 5 nice points. So here's my dashed line right here, and again, it's better for you to use your ruler. And again, there are 4 regions. We don't want to guess and check. That takes way too much time. But again, pick a point and decide which side of the solution the truth is on. And on this one, it's over here. And on the green line, it's below. And where these overlap is the bottom right-hand corner. So I'm going to pick a simple point 10, -10. I'll make a note of that because it's a bit of a weird one. So there's my 10, -10. And all I'm going to do is I'm going to make sure my graph is right. I'm going to make sure my solution region is correct. So with our blue line is -10 greater than or equal to -3 times 10 plus 9. Is -10 greater than -30 plus 9? Is -10 greater than -21? Yes. And our green one, is -10 less than or equal to -1/5 times 10 plus 9. Is -10 less than or equal to -2 plus 9? Is -10 less than or equal to 7? Yes, it is. So here's our right answer. So just as we solved our system of equations, pictorially works really good when things are nice. We pick a test point and make sure we're correct. So as before as well, we also have to be able to write the system. And in doing it, it involves writing the equation first and deciding on the inequality. So in this system right here, I'm going to call this one my blue one, and this one my green one. And again, you see the shading, you see the overlap. So I'm going to do the green one first, because the green one is y equals mx plus b, the slope is 0, and the y-intercept is -2. So the green one is y equals 0x minus 2. And in deciding, should there be a greater than or less than, again, we're simply going to pick a point and see if it works. So I'm going to pick 0, 0. I'm going to pick that one right there. So I'm going to leave it blank like we did. Is 0, we're going to fill in the blank. So in this one right here, what can we say about 0 and -2? Well, hopefully we say that 0 is greater than -2. So when I write my equality, I'm just going to do them on the right. We're going to have y is greater than 0x minus 2. And then we have to decide, is it a solid or a dashed line? It's a solid, so we have to include it. So there's one of the equations in my system. The other graph, the blue one I called it, again has a y-intercept of 3 and a slope of -2. So our equation would be that. And again, we're going to plug in a test point where the truth is, and the truth is to the right of this. So 0, 0 works as well. So I'm going to plug in that point, and I'm just going to decide on what the equality should be to make that work. And hopefully you see that 0 is less than 3. So in our other equation in our system, we're going to have this. And then we have to decide, do I include or not? And it's a solid line, so we do. So there's our system. So that's going backwards. That's using our picture, and that's a little bit more difficult. But if we remember the things we did on the previous 2 pages, you see how they're connected. So one last question, and this is what we're going to go on to in the next 3 lessons. We're gonna try to figure out a story. So this one's basically just, instead of me telling you stuff, I'm giving you a story. So here's a company. A company makes 2 types of boats: aluminum fishing boats and fiberglass boats. When both assembly lines are running at full capacity, a maximum of 20 boats can be made in a day. But the demand for fiberglass boats is greater than the demand for aluminum boats, so the company makes at least 5 more fiberglass boats than aluminum boats every day. So, and then the question ultimately becomes, what combination of boats could the company make every day? Well, this really comes down to, if we could draw the picture, then the answer becomes a lot simpler. So in this one right here, I'm just gonna label axes. I'm gonna call this my y-axis, and the horizontal my x, because I just want nice simple letters. But here's what I'm going to say. I'm going to say x represents the number of aluminum boats. So I'm just going to make it shorthand. And I'm just going to call y represents the amount of fiberglass boats. And given that I've represented these things, now all I want to do is look at these sentences and turn them mathematical. So in this one right here, it says a maximum of 20 boats can be made. So we can make, some of them are aluminum and some of them are fiberglass, and we can make a maximum of 20. So you can make 20, you can make 19, you can make 4, you can make 0 in a day. But that's what that sentence right there says. A maximum of 20 boats can be made. Well, then we have to look at this one where it says the company makes at least 5 more fiberglass boats than aluminum boats. And we have to write an inequality for that, and this would be it. So how we would represent that is, those are my fiberglass boats, and they make more fiberglass boats than aluminum. So if you make 1 aluminum boat, then you have to make at least 6 fiberglass. So what we're going to do is we're going to go ahead and graph those 2 inequalities. And again, I'm going to do this one blue, and I'm going to do this one green. And again, you could do this however you want, but I'm just going to find this 1, 2, 3, 4, 5. There's your 10. 1, 2, 3, 4, 5. There's your 20. 3. There's your 10. And there's your 20. So in going ahead and graphing this, we're going to graph each inequality. And I'm going to graph the blue one first, and you could graph it however you want, y equals mx plus b or whatever, but I'm going to use the x and y intercepts, or simply figure out some numbers. So if we had none of these boats, we'd have 20 of those, and we have 20. If we had 20 of these, we'd have none of those. And again, 2 and 18, 18 and 2, etc. So I'm gonna plot these dots. technically it can't be a line because you can't have part both, but it could be 1 and 19. But anyway, I'll just plot that and then I'll draw my line. And again, your line should be starting and stopping. We shouldn't really have that part right there. Okay, y is greater than x plus 5. Again, what we're going to do is we're going to go ahead and plot y equals x plus 5. And there's our 5 and a slope of 1. And again, it doesn't turn out to be a perfect little picture, but there's that one right there. And again, this one is supposed to be dashed, right? So again, when we connect the dots, it's going to look something like this. And in shading the inequality, well, we're going to shade underneath the blue. Again, do a test point, make sure you understand that it works. And we're going to do, so underneath the blue and above the green. And this is going to turn out to be the region where our solutions are going to be. And again, technically, there is going to be an in-between because I'm scaling in 2s. And if I should have had a bigger grid, that we could have went up to 20 in 1s, but I didn't. So in this picture right here, this is where your combination will be for each day. And if you want to make sure, you pick a test point. So if we picked, for example, 2, 10, and if we plug that into our first one, we'd have 2 and 10, and 2 plus 10 is definitely less than 20. And if we plugged 2 and 10, well, 10 is definitely greater than 7. We're going to continue on with these kind of problems over the next 3 tutorials.